welcome to section 10.2. Here are your answers for 10.1. We were working with graphing simple quadratics. And then today what we're going to be working on is graphing complex or general quadratics. Basically, where the yesterday we saw the b value wasn't there, it was 0. And today we're actually going to have a b value, and I'm going to show you what to do in that case. So if you have any questions on your homework, let me know. But today we're going to be graphing general quadratics, so ax squared plus bx plus c. So you're going to see this b value here this time. Alright, so just a couple of reminders from yesterday. If the a value, the a coefficient, or the x squared coefficient is positive, it's going to open upwards. And if it's negative, it's going to be a reflection, so it's going to open up downwards. Okay, and then we talked about stretches and shrinks. If you have y equals x squared, then y equals 2x squared would be a stretch. And then if it was like y equals 1/2 x squared, it'd be a shrink. Those are just a couple examples there. Okay, so a couple things here that are going to be of noteworthy. We've already talked about how if it opens up or down. We've talked about stretches and shrinks. Today, this is the new stuff right here. I'm going to go over all this with you guys. Axis of symmetry. This line, this axis of symmetry right here. Yesterday, it was the y-axis. Today, it's not going to be the y-axis. We're going to use this formula, x equals negative b over 2a. That's going to allow us to find the axis of symmetry. Now the vertex, the lowest point or the highest point on the graph, depending on if it opens up or down, is going to be on the axis of symmetry. So we're going to use the axis of symmetry to find the vertex. Also, the y-intercept is always when x equals 0. And I believe I have that on this slide here, right here. So when I plug in 0 in for x here, and here, that gives you 0, and that gives you 0, and so you're left with c. So 0, comma c is always your y-intercept. Kind of like when we did the y-intercept for a linear function. If you plug in 0 in for x, you get y equals b. That's that y-intercept relationship there. So let's go back to this here. Make sure we got everything. As I mentioned down here, the last thing, the axis of symmetry is always the y-axis. X equals 0. Today, we're actually going to have to find that. So I'm going to walk you through all this. You got some notes here, hopefully, now. And let's start with finding the axis of symmetry, and then we're going to find the vertex. So we're going to use the formula x equals negative b over 2a. So negative 12, b is 12, and a is negative 2. So negative 12 over negative 4, that gives you 3. So the axis of symmetry is x equals 3. It's an equation. It's always an x equals equation. Then what we're going to do is we're going to find the vertex by plugging in x into the function. Okay, so we're going to plug in 3 into the function. Negative 2 times 3 squared plus 12 times 3 minus 7. So that'd be negative 2 times 9 is negative 18 plus 36 minus 7. So that'd be 18 minus 7 is 11. So the vertex is the coordinate 3, 11. The vertex is a coordinate point. We're going to be using that. It's a very special point. It's one of the most important points on a parabola. All right, so we're going to go through all of the steps now to actually graph this equation. So we're going to step number 1, axis of symmetry. Negative b over 2a. So negative 6 is positive 6 because b is negative 6. 2a, 2 times 3. Okay, that's just 6 over 6, which is 1. Now we're going to, step 2 is find the vertex. And you know, it's helpful to state if it opens up or down. Just so that when you're graphing it, you know if you've done it right or not. So this one opens up because 3 is positive. Okay, let's find our vertex. Let's plug in 1 in for x. 3 times 1 squared minus 6 times 1 plus 2. That'll be 3 minus 6 plus 2, which gives me negative 3 plus 2 is negative 1. So my vertex is 1 comma negative 1. That's going to be important for us. Now when we're making our table, so we're going to make a table of values x, y, the vertex always goes in the middle. We're going to plot a minimum of 5 points, and the vertex is going to go 1, negative 1. Then we're going to go 2, 3, and 0, negative 1. You can choose the numbers that you want to plug in for x, but since this the graphs are symmetric, you're just going to plug in 2 points and then reflect them. As long as you have the vertex, go 2 above or 2 below, and then we can just reflect those. So I like using 0. 0 is an easy number to plug in. So when I plug in 0, 3 times 0 minus 6 times 0 plus 2 equals 2. That's easy. So that's why I like plugging in 0. Now I'm going to plug in negative 1 as well. So this is going to be reflexive here. So that's going to be a 2. I know that. So let's plug in negative 1. 3 times negative 1 squared plus, or is that minus? I think it's minus. Minus 6 times negative 1. Minus 6 times negative 1 plus 2. Okay, so negative 1 squared is 1 times 3 is 3. Negative 6 times negative 1 is positive 6. All right, so we have 3, 6, that's 9, plus 2 is 11. And there's my 11. And then I can reflect that point down here. And then I have enough information to graph my graph. Bring this down here. Okay. So I'm going to plot the vertex first, 1, negative 1. And this is my axis of symmetry. And then 0, 2. And then 2, 2. And then 3, 11 is going to be somewhere up here. And negative 1, 11 is going to be somewhere up there. And we have our beautiful parabola. And that's all there is to it. Seems like it seems like a lot of steps, but it's pretty straightforward once you kind of learn the techniques. Find the axis of symmetry, find the vertex, plot some points. Okay, let's see. Let's jump down to this example here. I'm going to start with negative b over 2a, so negative 12 over 6, 2 times 3. So that's negative 2. So my axis of symmetry, I'm just going to plot that right away. Find the vertex. Okay, so I'm going to plug in negative 2. 3 times negative 2 squared is 4, plus 12 times negative 2 minus 1. 12 minus 24 minus 1. And that would be negative 13. So my vertex is negative 2, negative 13. And that's off my grid again. So that's going to be down here. And then I'm going to plot some points. So negative 2, negative 13 is going to go in the middle. Choose 2 numbers above and 2 numbers below. In this case, I'm going to plug in the negative 1 and the 0 because those are the easiest numbers to plug in. When I plug in 0, you end up with 0 plus 0 minus 1 is negative 1. And when I plug in negative 1, I have 3 times negative 1 squared plus 12 times negative 1 minus 1. That will be 3 minus 12 minus 1, which is negative 10. Reflect and reflect. And then you can graph negative 4, negative 1, negative 3, negative 10, negative 1, negative 10, and finally 0, negative 1. There you go. So that's all there is to graphing a quadratic. Max and mins, if it opens up, it's going to be a minimum. If it opens down, it's going to be a maximum. So we can find those. Basically, it's just simply the vertex. If A is positive, parabola opens up. Therefore, there is a min. And if it opens down, there's, of course, a max. Okay, I'm going to show you guys how to find the max or the min now. So in this first one, a is negative, and so the graph is going to go like this here. So this is going to mean it's a max value. And then, so we're going to find the axis of symmetry first in order to find that vertex point. So negative b is negative 12 is positive 12 over 2 times a is negative 6. That gives me negative 2, so that's half of my answer. I got to find the y value, so I'm going to plug in the x value. So negative 3 times negative 2 times negative 2 is 4, negative 2 squared, minus 12 times negative 2 plus 10. So here I have negative 12, here I have positive 24, here I have positive 10. So that would be 12 plus 10 is 22. So that is my max value right there. My video is getting a little bit long, so I'm going to save this for class. And there you guys go. That's your assignment. Let me know if you guys have any questions, and we'll do a sample problem in class with the word problem, so you guys can review this concept. Thank you for tuning in to 10.2.